Begin to talk about the vibrometers. The vibrometer, again, by definition, is a sensor to measure the displacement. We trust the reading of the sensors. Hopefully, that reading is as accurate as possible to the real displacement, and that's the meaning of the measurement. Do the measurement. Okay, we trust. How trust we're going to make depends on how wise the engineer give us these sensors. So the key for learning this is I will show you how to pick a good sensor such that its reading is very close to the true one. Okay? So vibrometers is going to measure the using the reading. This is our sensor readings. The sensor reading is regarding the relative displacement, which means is indicated by these indicators. However, our goal is to use the sensors readings to approximate the true. True is y. So you can see this is our sensors reading. This is our true readings. They have a difference. They're a little bit different, right? How much difference? We'll look at here. We'll look at this one. I think we can start from here. So everything starts from these equations. And Z, what is Z? Z is the magnitude of the readings. Z is the representing the magnitude of the displacement. Again, in this application, the relative displacement represent is the sensor readings. So if you like, we can put in here and if you like, you can put a note here. So this is the sensor's reading. Okay, y is the true displacement to be measured. Okay, if you like, you can put a note here. Okay. So put the two notes onto here. Let me get the screen down a little bit clear. Okay. So now you can see right now come to justification. I think this is the value. You take the vibrations and come to these things. I try to make sure everyone get it. This is a sensor readings, and this is a true value. And our goal is we want to pick up a good sensor such that we trust the readings that is as close as possible to Y. So basically, how to pick up the sensors, how to pick up the vibrometers. A good vibrometer is such that this value basically, in theory, equal to this. Be good? In other words, a good vibrometer is such that this whole numbers equal to 1 in theory. Right? Okay, and look at this one, how possible, under which conditions this ratio equal to 1. We'll look at this curve. The curve really doesn't matter the damping ratio and the value of R, the whole curve approaching it converges to value of 1 here, right? Good? So in this way right now, if you be an engineer, how are you going to pick up a good vibrometer such that give us the very good approximation of this number equal to 1? How you pick it up? You say, hey, can we pick up, say, R equal to 100? That pretty much guarantee the value equal to 1. Yes, you can do it. You can do it, okay? And that is a good way to do it. However, many times the budget is limited. So right now I'm talking about the practical issues. A good one, for example, falling into this range, R equal to 100, for example. And that one, vibrometer is usually very, very expensive, super expensive, because they are very accurate. Okay, but if you only have 1,000, I can tell you 1,000, the range of the 1,000 sensor is falling into this range. Good. So right now, come to the real application trade-off between the budget, between the capability, and between the approximations. Good? Okay, so the remaining issue is that we know in most of these situations we won't be able to get one ideal sensor such that is equal to 1. So that means in most practical situations, they always have certain relative error between z and y. So that means this number we know in practice won't be equal to 1. Okay? Yes?
So the difference between an expensive one and a cheap one, would it be quality control or
Yes,
better materials?
you got it. Quality control. Basically that regarding this number.
Okay.
The cheaper one give us, say, for example, 80%. And a better one, say, 90%. And even better one, maybe 95%. Okay? So I think you got the point. So remaining the majority of the discussions on the vibrometers design and the pickup is really focus on the how good this number is close to 1. So that means derive we have called it relative error. And in the homework exercise, I precisely define the relative error or error percentage. And you can look at the homeworks. And I think that's due this coming Saturday. So from there, you can get more exercise how to do this one. So again, the majority is not to go to the ideal sensors, but however, to use your wisdom together with the budget to pick the good one, and hopefully that percentage error can be minimized. Okay? Okay, so that is the one here. So that's for vibrometers.